As some of you know, I spent over a third of my career negotiating contracts ranging from many ship types to one of the first MOD privatisation contracts through major PFI agreements and culminating with the largest global telecommunications network ever rolled out. As a result of this experience, and probably having spent far too long with lawyers, I'm always very keen to get the definitions agreed before tackling the serious content of the contract. So, from now on in this talk, whenever I say I, me, or we, what I really mean is the RNLI's technical team based in Poole. They are one of the very few fully integrated vessel design teams left in the UK. The lifeboats I will describe tonight have been designed from a clean sheet of paper, developed, built, put into service and supported through life by the RNLI team. Tonight I'm supported here by the leader of the RNLI's engineering team, Steve Austin, and I can't see him. He's hiding at the back, and Peter Eyre alongside him, who led the Shannon project design team. They are responsible for much of the content of my lecture, and of course they will answer all the difficult questions. In truth, they are my RNLI minders to keep me on script. Before I start the lecture, I must first give you a health warning. If you are prone to seasickness, I recommend you take your tablets now or be ready to turn away from the screen. Now for my lecture. Marine engineering, science and technology of saving lives at sea. Simply constructed from the name of our institute and the core objective of the Royal National Lifeboat Institution, as relevant now as it was when the institution was founded in 1824 by Sir William Hillary some 188 years ago. But a more accurate title would add in some naval architecture and saving lives on inland waters, on beaches and in floods. The first edition reflects the whole ship approach to design, while the second illustrates the wider range of services the RNLI now delivers while still firmly adhering to the core mission of saving lives at sea.
Falmouth Coast Guard, Falmouth Coast Guard, Falmouth ILB 16, over.
Humber Coast Guard, Sunderland Lifeboat, Channel 16, over.
Let's go! About there.
So what are going here, mate?
It's a sailing yacht, Fiji. Sailing yacht, Fiji.
Let's keep going.
No problem at all. That line would no bother, mate.
So the RNLI is a charity, independent of government funded, separate from the Coast Guard, and operates throughout the United Kingdom and the Republic of Ireland. Last year, lifeboats launched 8,905 times, rescuing 7,976 people. A launch for every hour of every day, with 4 out of 10 of those launches at night. 438 lives were saved, 354 by lifeboats and 84 by lifeguards. On beaches, the lifeguards operate from 163 beaches and attended 15,265 incidents, although it has been noted that 95% of lifeguard work is preventative. For 2013, we're adding a further 18 beaches with an eventual target of 300. The RNLI's aim is to end preventable loss of life at sea through coastal safety programs. Safety advisors run How Safe Is Your Lifeguard sessions, and we have led the way on standardising beach safety signage, which you will now see around the world. Through the beach safety program, the RNLI had contact with some 1.3 million young people. Last but no means least, the RNLI flood rescue team is made up of 300 specially trained lifeboat crew and staff members located across the UK and the Republic of Ireland. There is also an international capability. Much in action from Bangladesh to Cockermouth, the flood rescue teams have been very busy again this year. Before I run my next slide, it's time for some audience participation, for which there will be a small prize. All of those from the RNLI, including CEng, and I can't see where the chairman is of CEng, you're automatically disqualified from entering. If you think you know the answer, please put your hand up, as I don't want you all shouting out at once. Can anybody tell me the name of the nearest lifeboat station from where we are tonight? I'm going to take the first hand that went up. Well done, sir. So the answer was Tower. It's a misnomer, really. It originated when we first set up the service on the Thames following the IMarEST disaster. It was set up at Tower Pier. The station is now located in the old police station, floating police station, alongside Waterloo Bridge, outside Embankment Tube Station, but it's still known as Tower Pier, and it's one of 3 Thameside lifeboat stations. This is a map of all the lifeboat stations around the UK. As you can see, as the dots spread, it's pretty comprehensive, and it's now followed by the red dots, which are the lifeguarded beaches. A little bit behind date, because now the full Thanet corner is covered, and as I said, another 18 are going in. I've now got a sequence of pictures of lifeboat stations just to give you a flavour of what we've got. A slipway station, obviously surrounded by some pretty bad weather. This is a carriage launch station, lifeboat housed and then coming out on the carriage. You'll see a lot more of those later. And another slipway station. I can't remember where that one is. But this one shows you that our lifeboat station, this is Blackpool, are subject to the heavy weather as well. But I'll just leave you with the thought, we have to build them under those weather conditions. And of course, when you're building a station like this, and I think that's angle. So this is a very difficult station built down amongst the cliff of the rocks, a slipway station. And here you can see the framing and that going up. This is the Lizard. This is Shoreham, which is now complete, so just a couple of shots going through. I like that one at night. And some pretty heavy concrete pouring goes on for the slipway side of life. The reason I show you these is because I'm responsible for all these as well. So I'm a builder as well as a land builder as well as a shipbuilder, just to give you some idea of the scale of the thing. You might ask why these things are big, but of course in today's terms, this will come out in the talk about the training and now mixed gender crews. They do need quite a bit of space. And here we see the first splashdown. But what do we aim to do? Well, these are our service performance. Not targets, we've reached these. This is what we do. Average launch time of 10 minutes. We're notified by the Coast Guard, then we've got 10 minutes to get to launch. We've reached casualties out to 100 nautical miles in all weathers. And when you talk to the RNLI, we do mean all weathers. We reached 90% of those casualties within 10 nautical miles within 30 minutes, which obviously puts the pressure on what the performance of a lifeboat is, again, in all weathers. When we get to the beach, reaching a casualty 300 metres from shore within the flag within 3.5 minutes. 3.5 minutes, drowning time. And on flood rescue, we have 16 flood rescue teams within the British Isles, First two teams on the rendezvous point within 6 hours. Now, as a result of really the RNI's involvement, the flood rescue now in the UK is a well-coordinated, structured response, and the local police will become gold commander, and then we sit under a structure in there. But that's what we're achieving. And then secondly, finally on the flood relief, we can deploy an international team of 6 boats within and 25 personnel to any UK departure point within 24 hours. And that's to go anywhere in the world. So fully vaccinated, all ready for the different climatic conditions in terms of fuel storage and so on. This is just to give you some idea of the kit, the range of kit that's going on there. What we're doing essentially is deploying 25-knot lifeboats, and I'll just point to the sort of current sort of models, the Seven and the Tamar. Older models, the Trent at 25 knots, the Mersey and the Tyne at sort of the older classes at 17 knots. And then we've also got hovercraft, obviously places like Morecambe Bay, and then we come to sort of the inshore fleet with what's called a B-class or an Atlantic at 35 knots, D-class little baby for inside the surf line at 25 knots, and then the E-class on the Thames at 40 knots. On the beach, we've got the Arancia, which is the inshore lifeboat of choice for lifeguards, and a rescue watercraft, never a jet ski. Seven is a big boat, roughly in round terms 40 tonnes, 30 tonnes, and we'll get to the next one at 20 tonnes. Slipway launched, a float berth. For the lifeguards, they get the all-terrain vehicle, the quad bike in common parlance, and 4x4 trucks. And last but very much not least, the logoed bicycle. And what makes the RNLI different? Most importantly, it's the volunteer ethos that runs through the very heart of the RNLI. Our launch response times make 24/7 availability essential, with all that entails in terms of reliable equipment supported by backup cover. There is a very wide range of operating conditions, from river to surf, inshore waters to developed storm conditions, dictating the need for a very wide range of rugged equipment and a deep understanding of the environment in which our crews and boats operate. Because we do a job that no one else does, there is a need for bespoke kit. Off the shelf very often just won't do. This leads the RNLI to being responsible for the design, supply and support of complex equipment, often designed specifically for the job, requiring staff and volunteers to be more than just an intelligent customer. If a piece of equipment is damaged or broken in the far corners of the UK or the Republic of Ireland, the RNLI must retain the capacity and skills to sort the problem out. As a consequence, this leads to the development of our own design standards, certifying our own equipment, and the need to retain design authority for our equipment. But what else makes the RNLI different? It is an organisation of volunteers, 44,000 people, lifeboat crews, shore crew, sea safety advisors, and an army of volunteer fundraisers, including those who staff over 140 shops. Volunteers who selfishly devote their time, energy and courage to delivering the round-the-clock service and raising the huge sum of £160 million per year required to fund the service. These volunteers are drawn from many walks of life. Some years ago, all the operating lifeboat crew would have been drawn from the marine professionals, ex-merchant and Royal Navy, fishermen, harbour pilots, tugs, and the like. Today, there are very few professional seafarers, but the RNLI's training regime brings all volunteers up to be fully competent crew members. Normal people, extensively trained and equipped to save lives at sea and thereby minimising the risk. As the RNLI Operations Director often reminds us, we are in the risk business. So before we design a platform, we need to know what the crew face so that our platforms can safely undertake search and rescue operations. Have we got any volunteers to be a crew member? Here we see Mr. Schumacher having a bad day at the office and getting away with it. But what's the connection? Our equipment needs to withstand the worst conditions to ensure that our crews are protected and able to save life and not become casualties themselves. Be that through grounding, which can happen because of a product of the areas in which our crews have to go to carry out a rescue, or normal operation in conditions such as heavy surf. If they get it wrong in this unpredictable environment, we must ensure that the kit looks after them just as a Formula One car does, built to be driven hard in unforgiving conditions. This is the enduring challenge and the reason for our in-house design, construction and repair capability, deep expertise and knowledge of the environment. This is the challenge for an all-weather lifeboat. We need to operate at 25 knots with 17 knots in a 4.7, plus safe operation in 16-foot waves. As a result of this, we were ever more seeking more capable hulls and engines and better crew seating to protect them in heavy weather conditions. Here is a CMarEng class slipway launched all-weather lifeboat, ALB. Please note the innovation, pedal power to reduce fuel consumption. In fact, the last chief executive of the RLI was on a sponsored bike ride from Poole to Paris to raise money for the National Lifeboat Memorial, commemorating all those who have lost their lives on lifeboat service, and which is installed just outside the RLI headquarters site in Poole. Here she is in a more typical at-speed guise. I'm now going to take you on a guided tour of the layout of the CMarEng and give you an insight into the design issues and problems which have resolved in the development of the latest RLL all-weather lifeboat. CMarEngs are currently under construction but coming to the end of their production run. They're 31.5 tonnes, fibre-reinforced composite, 2,000 horsepower Caterpillar engines driving 5-bladed propellers and a crew of 7, including the doctor. Before we go through the internal layout, I'd just like to point out that tunnels and keel you're required that are essential for slipway work and for taking the ground without sustaining damage. Also, what's called a Y-boat is housed in a small recess under the aft deck. This facilitates both launch and recovery and leaves the deck clear above for helicopter operations and stretcher landing area. This one's been strung up. I'll just quickly flip through the slide because it's fairly self-evident of the normal sort of maritime spaces. Just to note, the survivor space has seating for 10 survivors and also houses the boat's batteries, electrical distribution, and the rack for what's called the Systems and Information Management System, or we call it CIMS for short. This is the CIMS system. It wasn't available off the shelf, and the RLI and Serverwatch have developed this system, and it's an integrated bridge system. It brings to each of the crew member control and information relating to the many systems on board, allowing them to undertake many tasks remotely from the safety of their seats. Important, since most of our common accidents are down to people moving around the boats at sea and falling over. All the data from the various onboard systems are presented on flat screens. And there you see a picture of it. In front of the crew in the wheelhouse and also on the upper steering position. These boats have an upper steering position as well as the one inside. This gives us the advantages, as I mentioned, of the crews are on seats and strapped in. There's less clutter in the wheelhouse and it reduces training demand because there's a common look and feel across CIMS now being extended into the Shannon class. And also I think reduced versions on the ILBs. All of this gives us greater systems redundancy. I mentioned crew seats just now. We'll now turn to crew seats. As you can imagine, the pounding that these boats take would be transferred to the crew. The clear need arose to provide additional protection for the crew from wave impact and vibration, especially so in extreme service conditions. This has led us to design a new crew seat. Having established the nature of the service environment and collected a massive vibration and shock data, dynamic models were created and validated against data. A human spine model was created and subjected to loads of fatigue prediction methods. Data on human tissue enabled injury prediction rates for different suspension seat concepts. It was evident that the existing designer seat was inadequate, and so a new concept for the suspension system was developed to maximise crew protection. Following prototype testing, vibration measurements demonstrated a much more effective seat, which is now in production and installed in the new CMarEng and Shannon class lifeboats. We use composite materials because their inherent strength to weight ratio, robustness, i.e. damage tolerance, with a long service life, you're coupled with low maintenance. With the right skill set and manufacturing condition, hull and deck houses are readily and quickly fabricated. First of all, there's a wooden mould made in one or two halves, depending on the hull shape. Then the outer skin is laid up and a vacuum applied, such as the resin, pre-impregnated resin, is poured through that initial layer of material, and the temperature is then raised or cooked. Then we'll add a foam core, and then the inner skin is laid up. And again, a vacuum applied to draw through the resin and the temperature raised. There are huge sort of bespoke-made ovens to do this work that fit around the hull mould. Here is an overview of the company called SAR Composites. This is the company that we took over from the owner and I took over from Green Marine a couple of years ago to bring composite manufacturing in-house. We have been able to bring manufacturing hours down for a Tamar hull from 18,000 hours to 12,000 hours are using, and this is specifically for the board of trustees to learn, using lean techniques. This factory is based in Leamington, and it will now be undertaking the hull moulding and deckhouse moulding for all of the RNLI's all-weather fleet. Now returning to the Shannon class ALB. Officially, the boat is currently known as FCB2, which means Fast Carriage Boat 2. She gets her proper name of an Irish river when she actually enters service. She is the first RNLI all-weather lifeboat to use water jets, which gives Shannon quite amazing manoeuvrability and the ability to work off the beach. So the layout generally follows that as seen on the Tamar earlier. In designing a new LB, it is our practice to build a prototype to test out hull performance of speed, seakeeping and manoeuvrability. And on this occasion, the use of water jets, about which opinion was divided amongst the crews. The first hull did not perform well up sea, although the concept of water jets was successful, and also we were able to develop the launch and recovery equipment necessary for a boat, which was larger than the Mersey it was to replace. So it was back to the drawing board, but first the problem. This is a complicated slide, so you have to concentrate. It's going to run a couple of times, so you'll get used to it. Top left is the inside the wheelhouse. Top right is an external view looking through looking forward. Just watch the movement of the guys in the. The next slide has no sound, as the language would be far too salty for a mixed audience. Suffice to say, it hurt. What was interesting about this particular experience is we'd actually had the boat in the water for 7 or 8 months, and we hadn't got this problem. And it was only when she was on a long passage to Gothenburg to take part in a mass evacuation trial, and she ran a steady course for an extended period of time, that the problem really became apparent. And then, of course, we went specifically looking for the problem, and that's the response. She wasn't going to be a lifeboat from that point on. Now we sought to find a final hull solution which would enable us to overcome the seakeeping problem. We use a test tank, and while tank testing gives you consistency, it constrains you in the transverse direction, not ideal when concerned about transverse slamming. Here we see the RNLI design running through a large slam event alongside the original prototype hull. Due to these limitations on tank testing, we also carried a lot of free running trials to give us some statistical rigour. You have to run a lot of these trials so that you get statistical rigour to the results, so you know you are seeing a true like-for-like comparison between the boats. Again, you can see the severe spike taking place on the red boat, which is number 4, which is the back one, which is the original, and the new hull is the boat in front. And you can see just by that simple demonstration, she's, although taking some big leaps, is riding more smoothly than the other one. By the way, the winning hull was the in-house design. To a certain extent, we were very fortunate in that we had a full-size prototype to test against the Mersey, and then also to compare with the model test tank results against the candidate hulls. And here's the final result. Just watch this boat stop and then accelerate. The Shannon has turned out to be an absolutely superb seakeeping boat, which is already gaining a reputation to rival the Mersey, which, as I've said, is a much-loved boat throughout the RNLI. The ride is amazingly soft, and the water jets give manoeuvrability, which will go a long way to de-risk the close quarters encounters where lifeboats do their business, passing tow lines, boarding vessels, passing across salvage pumps and taking on board your casualty. Alongside the Shannon, we've also designed new launch and recovery equipment built by Supercat. I will leave the slides to talk for themselves. That gives you some idea of what we're doing. In very bad weather, it's sometimes necessary to beach the lifeboat to enable a dry recovery. One advantage of water jets is that you can come much closer in without risking of damage to props and rudder, making recovery easier and safer. If you own a boat, don't try this at home. It gets better. Watch for the water jets as they kick in as she takes up to the water. Home and dry. As I said, if you own a boat, don't try it. I have to add, normally you put the Supercat back in the water and she drives on, then you drag it out in the water, and you don't do that. I couldn't resist doing this. This is for the Institute's board of trustees and executive, who would sorely be disappointed if I did not include a slide on lean. So here it is. It could be the subject of another 2.5-hour lecture, but I won't do it tonight. Suffice to say that the technique of lean has kept the RNLI's 2012 operating costs within 0.5% of the 2009 operating costs, while opening more lifeboat stations and operating on more beaches. We're on target to save £20 million of operational cost. I can commend the technique of lean, and there are the 5 principles. I'm very happy to give you a lot more on it if you ask me later. I just want to touch on lifeguarding and the science of lifeguarding. Well, lifeguarding is very much was was very much intuitive. Find out as you go, find out as you go type operation. We believed, that's the island I believed, that standards were required based on meeting defined performance standards. You might ask why. That's Bournemouth Beach. That was a record day, 340,000 people. But it's, in terms of visual appearance, it's pretty typical of say, an air show and a good day. I mean, good day in terms of weather. Now, I just pose you the question, now find your casualty. Surveillance is essential, both to be proactive and so prevent an incident, as well as very quickly responding to a potential casualty. As I said before, it only takes 3.5 minutes to drown. In conjunction with Plymouth University, eyesight standards have been developed based on field testing along with optimal surveillance techniques. I'd now like to close with a video which is as much to just tell you about the international work of the RNLI, but also to bring home to all of us who use beaches, have children and grandchildren.
Drowning is an epidemic. Every year it takes the lives of an estimated 1.2 million people. That makes it a bigger killer than malaria. Most drownings happen in the poorest countries, where it can be the leading cause of child death. But we believe we can help. The RNLI has years of experience in saving lives, at sea, on beaches, and in floods. Now we're helping other countries save lives too. We're providing them with the training and skills to help prevent drownings. This is Bangladesh, one of the poorest countries in the world. 18,000 children drown here every year. And the Bangladeshi people desperately want to stop these tragedies. March 2012, 2 RNLI lifeguard trainers arrived in Bangladesh. Their mission? To help set up the country's first life-saving club. "15 volunteers get a 10-day course in life-saving and become trainers themselves. That means they can share their skills with new volunteers. The future of one life-saving club is secured. Who knows how many futures they will secure? This is just the start. Just one example of a small intervention making a huge difference. We're running similar programs around the world. Within days of their RNLI training, the Bangladeshi lifeguards saved their first life. With your support, we can save thousands more.
I'd just like to add that the funding for that sort of work is done by where we sell consultancy services to, for instance, the Chinese. We recycle that money for the international development work. Thank you very much.
Well, thank you.